Hi guys. Let's continue from the last time where we stopped. Um, Last time we did generation. These are the generated outputs we got from the background model. Now we need a way to actually check the quality of the trained model. So for that, we have this probability matrix, right? And what we can do is let me just grab this part again here. And now let me do uh, prob small prob equals to capital prob of ix1 and ix2, and let me print the f string. This is called an f string, and here I want to print ch1 and ch2. So let me first print just ch1 ch2 for let's say 2 words. Let me do this. Now you can see that we have all the characters in the first 2 words printed. Now, what if we print the probability of these bigrams, basically, of A coming after dot and A coming after this A. So these respective probabilities, which are the conditional probabilities on one character. So a bigram is basically a conditional probability given one character, what the probability of the next character would be. This can extend to trigrams, fourgrams, and like big context also. So let me just print this here, probability, and let's see. So now these are the probabilities we got. If you look at them, let me just format this dot 4f for 4 decimal places. Now if you look at this, 0.12 is basically 12% probability. Now this is 12%. Here we got 33%, which is quite a lot. This is 41. So uh, this is a very basically nice prediction. And if this is 1, basically we have accurately predicted what should be the next character. Now, what should be the trend of this? Now we need one number to understand the the quality of that model. Now this probability is okay, but how do we know that our model is well trained on all of the text, or let's say all of the multiple predictions? So we need some kind of a loss. Now, one thing which comes to my mind is we can have a loss. Let's say, um, if you think of it, what should be the trend? Now, the trend should be the smaller the probability, the more wrong is our prediction, right? So the loss should be quite high. And let's say if it's close to 1, the loss should be 0. So the first pattern we can have one thing is just 1 over x, which is 1 over probability. So what would this look like? So let me just print this also uh, here, and then let's print the loss as this loss, and again format it to 4f. Now if you look at the loss here, this is 66 somewhere, 3 somewhere, which is quite nice, because if this is 0.01, this is a very wrong prediction by our model. So that's why the loss is quite big. And the 41%, you can see the loss is very small, 2.4. This is a quite good model, but if you think of it, when the probability reaches 1, the loss should be 0. So 1 over 1 is actually just 1. So one thing we can do is just subtract 1 from this. So now you can see this is quite a nicer loss, right? And to keep a keep an eye on all the things happening, we can just take an average of them. So I can have some counts which is 0, and I can have what do you say, loss equals to 1, and I can just increment counts here, plus equals to 1 at the end, and I can also do an average of the loss. Loss sum equals to, plus equals to loss. But now summing this loss is not the right thing to do in language modeling. Let me just see what we get here. So I can just, after doing all this, I can just print log sum, and I can do here loss sum. And I can just print this plus minus, not plus minus, loss sum plus equals to loss. So now you can see loss sum is basically 224, and I can just print the loss sum by the counts. This comes out to be 14. So 14 could be a nice loss to use. But again, the problem here is, firstly, there's something called as a likelihood. Now, what is a likelihood? Likelihood basically means given multiple events, which these are, if they're independent events, the probability of everything happening together is just the product of them. So because they're independent events. Now, the product of all these probabilities, if you think of, would become a very small number. And when we want to, train using, or let's say get a loss, which represents all the all the examples which we have, this actually becomes a very small number. So if I, somehow just loss is 1, and if I, just comment this part out and comment this part also, and now if I, loss and if I just do plus it, star equals to the prob. So if I print this now, you see very suddenly the loss becomes 0, and this is actually a good number, but it's very small. And then later on, if you exponentiate it or do something, it won't be right. So what people have come up with is something called as log loss. So let me just copy all of this here, and just I want to delete this. I'll just delete this, and here what I'll do is I'll also delete this. Just print this. Yeah. Now loss, if it is just so yeah, let me just show you one thing. This. So why were we taking 1 over x? Here, if you see, this is the plot of 1 over x, and just move this 1 over x. Yeah. So if you look at this, when the x becomes infinity, the thing 1 over x function becomes 0, and when the thing becomes very small, This is close to infinity. And what we used, the previous loss was this 1 over x minus 1. And this you can see here the thing becomes 1, uh, the 0 at x equals to 1. So in the above thing with log sum, 1 over prob minus 1 actually is a good loss for a single example. Um, and so this is an ideal behavior we want for loss. So now that what we are doing here is we are just going to do numpy dot log uh, of prob, right? Uh, this is log loss, and yeah, so log loss, and here let's print the log loss here. Now if you see the loss, okay, so firstly why we are taking a log here. So there's this property of log basically, which is log of a star b star c is actually log of a plus log of b and plus log of c. So we this product is basically the likelihood, and we are taking a log likelihood. So likelihood is just the probability of all the events happening together, and then log likelihood is this. So this property we can very well use, and that's why the loss basically can be just plus equals of the log loss. So and then what we do is just print the log likelihood log likelihood. So yeah, so this is the likelihood and we are taking log of it. So that's why we got the log likelihood um, as the loss. So log like this loss basically is the log likelihood. And if I print this, this is minus 31. But now if I look at the log of x, this graph is very much what we want actually, because this graph tends to become minus infinity at probabilities very close to 0, and it becomes 0 at log of 1, x is 1. So this is something which is desirable, but a loss cannot be a negative number, right? Because we want to minimize the loss always in machine learning. So that's why what we deal here with is the negative log likelihood. So we'll just print the negative log likelihood is minus the loss. So here also we can just, okay. So here the number is 62. And what we can do here is the final loss is just the average of it. So average of the negative log likelihood basically sorry yeah so this is negative of the loss, and this has to be divided by counts. Yeah, so here, my bad. So you can see 6.2 is the right loss we are looking for. And this is how, using this property, we mostly use the negative, average negative log likelihood to find the loss of the thing. And this actually like tends to behave the things we want. So this 6.2 is actually quite big a loss because these predictions are quite low, 0.03, 0.03, 0.01, 1%, 3%. So a well-trained model actually should predict better than this. So one way to look at this is by doing, what could a model which basically just predicts random, or let's say average of the all the probabilities. So we have 29 as vocabulary, as you know. So what if we just, rather than plucking out the probability from the probability matrix, just do probability equals to 1 over 29, giving equivalent probability to all of the elements. What would this lead to? What do you think? Oh, let's just do this. Okay, so the loss actually increased. Um, so which suggests that the model, bigram model, is actually better than the just the random prediction model. This is changing. Oh, sorry. So this is actually adding. So let me do, yeah. So 2.09 is the trained model. And what if I do probability of 1 over 29? 3.36 is basically the random prediction. So yeah, so we found this is basically the negative log likelihood loss. So uh, let's try the trigram language model, which basically would use two context. Now we are using one context. Next, we can use two previous characters to predict the third one. I want you guys to try that out, and I'll show you how it's done in the next video. So thanks for watching. Bye.